This is Algebra 2, Lesson 1-11. We are talking about restricting the domains to make functions invertible. So, last time in Lesson 1-10, we talked about the horizontal line test to test if something is invertible. And today we are going to use that in conjunction with restricting domains in order to make sure they're always invertible. All right, so we have some keywords today. Domain. What the heck is a domain? This is review all the way back in Algebra 1. Domain. What are you? Quiet raise hand, anyone? Domain. Uh-oh. This is what happens when we have 3 days without Mr. Sindel. Domain. No one? All right, Mr. Sindel will give you this one. So a domain is all values of x that can go into a function. Keyword here being x. Range is y, domain is x. Yeah, so it's by restricting the domain, we're saying, hey, you're not allowed to plug in that number. So James, you can't plug in -10, for example. I'm restricting the domain by saying he can't plug in -10. So if I come out here on the x-axis to -10, I won't have anything that intersects the y, or the curve of the function. All right, interval notation. This is an example of interval notation. And from here, this is saying that x, the domain, is being restricted by -2 and 4. Specifically, that x is greater than -2, which means x can't be less than -2. So here's -2 on a little graph that I showed you. That means everything, go ahead and draw this line also on your notes, everything left of here, you are not allowed to plug in. Everything over here, you can't plug in. There's nothing over there you're allowed to plug in because we have restricted it so you can't be less than 2. You have to be greater than 2. So don't worry about this area. And I also have x is less than 4. It's a compound inequality. I don't know if this is, oh my gosh, I made an error here too. Can we cross out interval and say that this is inequality? This should be inequality notation, not interval notation. Interval notation is if I did this, like from -2 to 4. That's interval notation. I'm trying to do inequality notation, so sorry about that. All right, and x is less than 4. That means if I draw a line x equals 4 right here, I am not looking at anything to the right of that. So specifically, this, by writing some function between -2 and 4, I'm specifically looking at that function in this range that I haven't scribbled out. The function only exists here. If it was the function y equals x squared, then I would have something that looks like this, and it stays in the function. But as soon as it touches that line, zap, it gets zapped by the bug zapper. We don't go beyond that point. We stop there. It is restricted. Nothing exists over there. It is blank. We're okay with how inequality notation works? All right. All right, this is a review from yesterday. The most important thing that needs to be in your summaries, because there's a red star, if you draw a horizontal line and it crosses the graph more than one time, then what can we conclude? Quiet raise hand. Quiet raise hand. Gio has an idea, sounds like? Horizontal line test. All right, go for it, Gio.
It's not invertible?
Yep. It is not invertible. And you can draw that horizontal line wherever you choose. In fact, you should try to strategically choose it such that it passes more than one time. And a lot of times it'll cross quite a few more times than that. So let's check it out. Here is a graph that I made for you. Is this function invertible?
Yeah.
It is invertible? No, it's not quite invertible.
No.
No. But why? Why is it not invertible? Gio, you want to get the door for us? You want to get the door for us? You got it, James? Exactly. It doesn't pass that horizontal line test. Because if I were to, say, draw a horizontal line like so,
Oh.
this crosses one time. Okay, so far, so good. It's still invertible. Second time, not invertible. Definitely not invertible. Oh, so not invertible. I wasn't even close to being invertible. It crossed way more than one time. You can draw that horizontal line almost anywhere on here, and you're not going to get this to be an invertible function. All right, so it's not invertible because it doesn't pass the horizontal line test. But today is all about trying to make it invertible by restricting the domain, by saying, hey, only look at this function between here and here. So let me give you an example of where we can make this interval. And I guess this stuff is kind of in the way, so I'm going to get rid of it. We can make this function pass the horizontal line test by, and I mean, you just have to regurgitate what I'm saying here, by restricting the domain. So by restricting the domain. For example, if this is the function, we should label this also. Let's call this function f of x. If this is the function of f of x, then I can restrict f of x by saying x has to be between these values. For example, x has to be between -9 and -5. Between -9 and -5. If I restrict it to this domain, it is now invertible because what I've done by restricting it between -9 and 5 is I've cut off 5. You don't need to write this down. And everything over here doesn't exist. It only looks like this line. Now the function is invertible because if I do the horizontal line test, it only crosses once. So by doing this domain, it's invertible. You can do it with quite a few other domains. For example, I could have done from -9 to -8. That function is also invertible. It's a tiny piece of the function from -9 to -8, but still that little piece is invertible because it passes the horizontal line test. Anyone want to try to find another interval that's somewhere greater than -5, somewhere over here on the right-hand side?
-5 and -2.
Yeah, -5 and -2. That's a good one. -5 is less than x, which is less than -2. Good job, James. Anyone else want to find another one? Someone new?
I do.
Hold on, give it to someone new. I want everyone to try to get XP here. Between -5 and -2, that's an invertible function.
Between 1 and 5.
Between 1 and 5, yeah, that's an invertible function as well. So you can say between 1 is less than x, which is less than 5. That's also invertible. Anyone else? There are an infinite number of intervals that you can choose, so you just need to choose a few of them. You just need to choose one if you're a single person. Steph, Chris, you want to get your XP in? From 5 to 9, yeah. 5 is less than x, which is less than 9. That's a good interval. Chris, any other intervals that you see? No? Okay. I could have done from 2 to 3. I could have done from 3 to 4. I could have done from 4 to 5. I could have done from 5 to 6. There are an infinite number of intervals that would have worked here. Some pieces might be bigger than others. The biggest possible piece that I can have is kind of between these tips here where they turn around. So between this -5 and -2, between this -2 and 1. But of course, they can be much smaller than that. All right, so let's look at an example. This is modified from Khan Academy. So it's very similar to what you'll see on Khan Academy. All right, can I get a reader to read example 1? Free XP here. Go for it, James.
To which intervals could we restrict the domain of f to make it an invertible function? Choose all answers to that.
All right, so we need to choose those intervals. So let's check those intervals. Let's check the first one. Let's check A, -7 to 5. We're trying to make it invertible. If I go from -7, so I'm crossing it off right here. Everything past here doesn't exist. That's -7. I came up to the x-coordinate -7 and crossed all that out. And I come up here to 5. 5 is right here. What do we think? Yeah, that one's clearly not the case. What about... Yeah, and it's because I could draw a horizontal line right there, and it crosses through multiple points still. What about from -2 to 1? So -2 is right there, to 1 would be right here. That is one of them, yep. So it says choose all answers that apply. It's not just one, it could be multiple. Okay, so that one works. What about from 2 to 5? From 2 to 5.
Yeah.
Gio says, yeah. I need to hear more voices.
Wait. No.
James says, oh, okay. So James is saying yes. Gio saying no. Steph, Chris, take yes or no, 50-50.
Yeah, actually, I didn't know, bro. I'm gonna say yeah.
Okay, and Steph, what do you think? Yes? So this one is actually a trick question because it kind of turns around
Yeah.
right before 5. So if I drew my horizontal line right here, it would cross twice. So this one's actually no. That one was really close, but not quite. So let me come back here. Really close, but not quite. Not A, not C. Let's check D. -6 to -4. So -6 is right here. Don't worry about this stuff. And to -4, that's right here. So is this function right there invertible?
Yes.
It is now invertible. It passes the horizontal line test. All right. What I want you to do is to work on example 2 in pairs. So Gio, you're working with Steph. Chris, you're working with James. And choose all the answers that apply for example 2. And we'll come back. We're back. So we're going to shout out the answers. So class, is A an answer, yes or no?
No.
No. What about B?
Yes.
What about C?
No.
What about D?
Yes.
All right, there's our answer key. Any questions on the notes?
No.
All right. The same monotonic no. Go ahead and write your summaries. Check your summaries with people in your group, and then you can begin on Khan Academy.